Okay, we will continue with the graph questions, with the graph. Isaac, hello. Okay. Give me one moment. Okay, question 2.2. So, right, last week we had an intro question, just one question only. Now we're going to do more of it. Okay. If you have any questions with the objective questions, to those of you who have already done, there is actually some questions which are quite interesting one. And I feel like some of the questions in the topic 2.1 for the objective maybe belongs to 2.2 also because of the graphs and stuff. But never mind. Okay, jumbo a bit. Right. So 2.2. The diagram shows the motion of a ball moving from point O to point A in 10 seconds. Okay, so point O to point A in 10 seconds. This one took 10 seconds. And then immediately reverse direction and to reach point B. Okay, reverse direction to reach point B in 5 seconds. So this motion, straight away reverse direction, this one, takes 5 seconds. Okay, sketch a displacement time graph for the motion of the ball. All right, so displacement time graph. Let's see. We draw a graph first. At first, we analyze out. At first, we start from 0, and then we go 50 meters away. Okay, we go 50 meters away. So remember, displacement is like the coordinates like that, right? Displacement is like the coordinates like that. From 0, you go until 50. Okay, and then after that, you come back 35 meters from here. Okay, 35 meters from here would actually mean that this value is 50 minus 35, which is 15. If I want to find out the coordinates, right, then this is going to be 15, right? So all these 0, 15, and 50, they are all the displacement value. Okay, they're all the displacement value. But usually we put time down here one. Okay, if you're not sure whether or not there will be a negative displacement, maybe never mind. We leave some space. Who knows, maybe there might be or might not be a negative displacement. That is if you're not sure yet. Okay, so we're going to start with 0 meter and 0 seconds, right? On top here is displacement, S. The side here is time, T in seconds. So at first, the ball traveled from 0 meter to 50 meter. Okay, 0 meter to 50 meter. And how long did this ball took? How long did this ball took? 10 seconds. So here we're going to put 10. And then here we're going to put 50. Right, 50. So I think a lot of people, right, they will now start to think, okay, I have gone 50 meters away from the original position. O is the original position. And right now, I want to go 35 meters back. Go back means go back where? Go back towards the origin, right? Towards your original position. So that would mean you are going to go closer and closer. Remember your y-axis is the displacement. Okay, it's the displacement, it's your position. So you're going to get closer and closer to the origin again, which means from this point, now you're going to come down, right? If I say that you're going to touch the 0 line, it means you go back exactly to the origin at 0. Remember, it's like a coordinate like that, 0, 0 meters. But what if they say you travel 35 meters? That means from here back to here, I must travel 35 meters. Okay, that is why when you put down the value, if you go and say that this value here is 35, then wrong already. Why? How come is it wrong? Because from 50 meter until 35 meter, isn't that just 15 right? But we don't want 15, right? The ball traveled back 35. So if I want here to be 35, that means here should be a value of 15. Okay, so that's why at the beginning, before I even sketch, I already told you all these coordinates, all this position. The 0, the 15, the 50, these three values you need to remember. They are just the position of how far away is the ball from the original position. When your ball is here, how far away is it from the original position? 15 meters. That is why the displacement is 15. Okay. So usually we put dotted lah, this one. Right? Please don't write 5 seconds here. Please don't write 5 seconds here. You took another 5 seconds. So 10 seconds plus another 5 seconds, that would be 15. Huh? At first you took 10 seconds, and then after that you took another 5 seconds. So it's 10 plus 15 like that. Okay, so there is no negative displacement. Why? Because the ball did not travel pass through the origin, but this is 0, didn't pass through the origin and go to the opposite side of the origin. Okay, didn't go to the other side of the origin, right? It all remains on just one side. So if you see all is on the same side, usually it's on the right side, or all is on the left side maybe, then it's all just going to be either all positive or all negative. Okay, if it's just one side, unless it has traveled past the original point and has gone to the other side, then only you have negative displacement. Just remember, if you ever get confused of what displacement is, tell yourself that it's the position of the ball at that point from the original point. Okay, the position of yourself from the original point. How far away are you from the original point? Okay, at this point, the ball is 50 meters away from the origin. Makes sense. At this point, the ball is 15 meters away from the origin. Okay, so this one I can rub a bit because you didn't have to use the negative side. Must have all these values, label nicely the units and label nicely all the units and the symbols S, T, then okay, all these 4 values need to have. So in part B, calculate the average speed. Okay, for the average speed, right, it will be total distance that it has traveled divided by the total time. So let's do average speed, total distance. At first, travel 50 meter, and then travel another 35 meter, total travel 85 meter. We will add them up later. And the time taken is 15 seconds altogether, the entire journey, go and come back, 15 seconds, my bad, 15 seconds. So it's 85 divided by 85 meters divided by 15 seconds. The units in your working, not important, never write 1 minus mark, is fine. SPM and your school exam should be the same, but the final answer must have the unit. Okay, 5.67, good enough. You want to write more a bit, can, but don't write too long now. This is already good enough, 5.67 meter per second. Average speed. Okay, average velocity. Is equals to, I need your help with this one. Can you all tell me what is the displacement at the end? What is the displacement at the end here? 15. Yes. Thank you, Jashan. That's good. 15, right? Displacement. Think again. If I ask you what is the definition of displacement, remember I always tell you shortest distance from the starting point to the end point. Okay. Starting point is right here. End point is right here. The shortest distance is only 15 meters. Very good. So it's just 15 meters divided by 15 seconds. Okay, because the entire journey took 15 seconds. That would be 1 meter per second. That is your average velocity. Okay, then last part, calculate the velocity of the ball in the first 10 seconds and in the last 5 seconds. Right, now it's not for the entire journey, but only for the first part and the last part, right? So, okay, maybe D I put down here, not enough space. Velocity of the ball. I have S graph. I want to go forward to find V velocity. Okay, find velocity. Well, if it's for average, then it's the whole journey. We just put down the total. Okay, but if you want to go forward, we are going to find out the gradient. Remember, I told you very important one is to remember the order. S go to V go to A is finding the gradient, right? So we are going to find the gradient in the first 10 seconds. What is the gradient of this line? One thing for sure that we know is that this straight line, because it is a straight line, it only has one value for the gradient. At any point on this line, the gradient is equals to the same value. Okay, so what is the y distance? 50. What is the x distance? 10. Okay, so the velocity in the first 10 seconds would be 0 to 10 seconds, would be 50 meters divided by 10 seconds. 5 meters per second. Okay, and then for the last 5 seconds, that means from the 10th to the 15th second, the velocity is, okay, this one be a bit careful because slanting this way, going down is a negative gradient. Velocity is negative, okay? Velocity is negative. Negative. What is the y distance? 35. What is the x distance? 5. Okay, it's y over x. Right. Just because it is a negative value does not mean it is traveling slower. In fact, the ball is actually faster when it comes back. Okay, 7 meters per second actually is faster. It just means that this one is going to the right. This one is coming back to the left. Change direction. All right. So velocity, positive or negative value in this topic tells you about the direction. Okay. Displacement tells you about the position. Acceleration tells you about the whether you speed up or slow down, and the plus minus sign. All that must know. And that's it. That's the whole question 2.2. Okay. Got any questions? Please ask me. Okay, please ask me. I think some of you also preparing for exam again. Can explain D again. Okay, can Sandra. Right. So first of all, if I want to find velocity in the first 10 seconds, in the last. So to those of you who are okay already, you can try to do the objective questions. Don't need to wait for me. Okay, I'll explain to those who need help with D again. So I have the displacement graph and I want to find out the velocity of the certain sections only, right? So I'm going to find out the gradient, the gradient. Okay, if the confusion here is you are not sure how to get gradient, okay, gradient is, the symbol is M, then we can go through again the normal formula that you learn in maths in form 2, okay, y2 minus y1 over x2 minus x1, okay, which is also the same as the y distance divided by the x distance, I like to call it. Okay, or some people may write it like this, the triangle y, triangle x. Triangle means the distance, okay? Triangle means the distance. So let's say, I think some of you may be more familiar with this formula. If you want to do this, just go ahead, just go ahead. Then you will need the coordinates though. So I will point out what are these two coordinates. This one is 0, 0. This one is 10, 50. Okay, so the gradient of this line will naturally give you the velocity already, right? That's why I say you have to remember this. The gradient of it going forward is fine gradient will naturally give you the velocity already. Okay, if you ever forget, you look at this 2.2. This first thing you see in this table, displacement to velocity to acceleration time graph. Go forward, find gradient. Go backwards, find area. Okay, so back to here, formula. Let's say I do y2, which is 50 minus y1. Okay, y coordinate minus y coordinate over x coordinate minus x coordinate. I'll get 50 over 10. That is 5 meters per second. Okay, I get a positive value, right? Which means it is going to the right. And you look at the diagram, originally it's moving to the right as well. Then now after that, it turns back. Okay, now it turns back. The blue color part is, it goes forward. Then after it turns back. So for the next part, I'm expecting a negative velocity. But let's say if you want to use the formula, then this one would be 15, 15. Okay, the gradient would be y minus y over x minus x. Okay, you type that, you get -7. So you can use this method if you want. Okay, usually when it comes to like experiment and stuff, when it's a bit difficult to get the y distance and x distance, then okay, I'll use this. Or else, if I can clearly see what is the y distance over the x, because y minus y meaning the y distance. Okay, that 35. X over x meaning the x distance. Okay, that's what I mean by y over x. The y over x. Okay, all this in your chapter 1, you all learn. Right, y over x. That's why you get -7. So if you want to find gradient, now you know. If you want to do y2 minus y1 over x2 minus x1, the plus or minus sign is taken care of. If you want to do the y distance, the one that I usually do, over x distance, then you have to put plus or minus yourself. Okay, then you have to put plus or minus yourself. So going up, if the graph is going up, it's positive gradient. If the graph is going down, then it's negative gradient. Okay, I think it's, in a way, it's better for you to know this. Okay, you can choose to do this, but you should know about that also. Because I think it's good that at this point, you are more aware of how the graph slopes upwards or downwards, and you will know from there, without calculating anything, whether the velocity or whether this ball or car or anything is moving forward or backwards. Okay, so if you see a positive gradient, positive velocity going forward, negative velocity going backwards. Can? Okay, welcome. Okay, don't worry, if really still a bit shaky with all these things, we do a couple more. Okay, if you really find that it's a bit hard to get, and then after that, after class, you go through yourself, you still don't really get, you can always WhatsApp me. Okay, I'll try to help you. Can? 2.3. Okay, because this is just the first two questions. We can do a bit more first. Then you have a lot of questions in objective. You can slowly practice there. So, okay, the objective, trust me, it will really help your understanding. Yeah, really help your understanding. Okay, so the figure shows the velocity time graph of a car traveling to the east. In case you have forgotten, this is north and south, and this is east. This one is west. So east actually means to the right side. Okay, east actually also means to the right side. West means to the left. And then travels in the opposite direction for a while. So the opposite of east is west. Okay, this one actually means west. first question. Okay, first question. Oh, oh yes, Jashan. Thank you. Sorry, I forgot. Yeah, I don't know what happened. I accidentally missed 2.3. I'm so sorry. Okay, I'll go back to that later. Yes, thank you, Jashan. Thanks. Okay, 2.3 first. The velocity time graph shows the motion of an object. Find the velocity when t is equals to 5. Okay, be careful. Read the title carefully. Read the axis of your graph very carefully. Okay, this one is what graph? Velocity graph. Okay, velocity graph. So you can draw a small one, S to V to A, and you circle what you have. You have V. So if the question asks you to find distance, displacement, that means go backwards, you find the area. If the question asks you to go and find acceleration and all those things, then you go and find the gradient. So moving forward, S to V to A, find gradient. Moving backwards, find area. Always remember that. That's the most important thing in this topic. Okay, so part A, I got a velocity graph and the time is 5 seconds. They asked me, what is the velocity at 5 seconds? That's just reading, right? That's just reading the value, right? So at 5 seconds, oh, it is 10 meters per second. Don't need to calculate anything. This is what we call in chapter 1, interpolation. Okay, interpolation. That means you read the values from the graph. Interpolation. So part A1, 10 meter per second. Okay, part A2. 18 seconds. At 18 seconds, it's an easy one. We go through quickly. The velocity is 18. Okay, 18 meter per second. Just reading values from the graph. They ask for velocity, and this graph is velocity already. So don't even need to count anything. Part B. Okay, find the displacement at the given time intervals from 0 to 5 seconds. Yes, very good. Justin said it's area under the graph. Very good. So how come I know? Because I'm always looking at here, right? I circled the one that I have and I'm moving backwards. Find area, right? Find area. So 0 to 5 seconds, meaning from here until here. The graph looks like this. When we say area under the graph, means under like that. Okay, means underneath like that. So it's always the sandwich part between the graph and the x-axis. Sandwich part between the graph and the x-axis. Okay, so what is this shape? It's not a foreign shape, right? It's a triangle, Nima, right? Triangle. So I hope you are okay with the triangle formula. That one, not sure. You need to go back and revise again. 1/2 times base, which is 5, times height, 10. 25 meters. Okay, half times base times height. Okay, half times base times height. And it's very natural one, because how come by getting the area, I would always get the displacement? Because if I go and multiply this one, the base and the height, the base here is in seconds, the height here is in meter per second. So you have meter per second. And then you go and times with second. The second and second will cancel out. And naturally, it will be meters already, right? So don't have to go and figure out every time you see the question, because if you remember this, you are very good already. Okay, you are good to straight away do it. Okay, you got V. People ask you for the one in front, find area. People ask you for the one behind. Yeah, people ask you for the one behind, you find area. In front, you can find the gradient. From 5 to 10 seconds, same stuff. This time is just a rectangle. Okay, can you all do this? Okay, you all do this first. I give you all 30 seconds to find this. And then after that, you have part C, also do part C, which is this, 14 to 24 seconds. Okay, this one a bit trickier, because this shape now has 1, 2, 3, 4 sides. But then it is not any shape that we know. Usually only 3 shapes. Triangle, square or rectangle, and then also trapezium. Okay, these 3 must know lah. Okay, these 3 must know. I give you the formulas if you need. So not all the time you can get the area straight away. For this one, I give you a small hint, you need to cut it like this. Okay, so you see this one trapezium, this one triangle. You just add the two together. Okay, you want to cut further and so on. Let's say you don't like trapezium. Some people don't like trapezium. They want to cut further into triangle plus rectangle. Can or not? Can. Up to you. Okay, just one more step lah, but then up to you lah if you really don't like trapezium. Okay, for some reason. So if you need the formulas, triangle, half times base times height, rectangle, base times height, trapezium, this is the parallel side, 1/2 a plus b times height. Nah? Okay, 1/2 a plus b times height. Go and do part 2 and part 3. I give you all a short while and then I will write down my answer. Okay, part 2, from 5 to 10 seconds, the object has traveled for 50 meters. Okay, in this time frame, it has traveled for 50 meters. You should be able to get 50. Next one, the displacement would be the trapezium is half and then 5 plus 18 times the height here is 4. Okay, 14 to 18 is 4. And make sure you know how I got the trapezium. If not sure, let me know. This is 5. Here is 18. That's why you have the 5 plus 18. The plus, the place where you plus is the parallel sides, right? And then the height has always to be 90 degrees to the A and the B. Okay, that is 4. You can plus one shot, then you still have one more triangle. 1/2 times base is 6, height is 18. Where do I get 4? Courtney, okay. Courtney asked me where do I get 4? There, do you see from 14 to 18, this height here? Right, 18 minus 14 is 4. Okay, so maybe I show you guys. So what I did was, here is 4, here is 5, here's 18. That's how I got this. Then this one, here is 6, here is 18. Okay, so calculator time. You can type the whole thing out, but if you do the whole thing one shot, just be careful. Make sure you have enough brackets and all that stuff. So here will be 46. That's the trapezium part, which is the 14 to 18 seconds, that part. Okay, and then we have 54. That's the last part. Okay, that's the last part. The 18 to 24 second part. 100 meters. Okay, 100 meters. Everybody can get? Cannot, must voice out, no? Okay, so you can see actually in this question, I'm trying to practice with you the thing that I always say is the most important, because in part B, we are asking you to find out the displacement. Okay, we're asking you to find out the displacement, which is to find area. In part C now, we are going to find out what is the acceleration. So I got a V graph and I want to find out acceleration. Go to the front, right? Go to the front is find the gradient, find gradient. So gradient, go behind is area. Okay, just remember that, you will be fine. Okay, so acceleration in the first second. Part B, okay, everybody. Okay, acceleration in the first second. Okay, I'm gonna rub off already because it's a bit messy here. Right, so here's 0 and here's 5. 1 second would be somewhere here, lah, right? And just remember that I want to find gradient. Ma. Am I right? The gradient at this point, 1 second, at 2 seconds, 3 seconds, 4 seconds, they're all the same because it's all on the same straight line. It's a straight line. So straight line, they should have the same gradient value. Okay, same gradient value. To those who prefer to do y2 minus y1 over x2 minus x1, then you can start to write out your coordinates really. Okay, and then you can do the formula. For those who want to use my way, which I feel it's not to say better, it's not really better, but I feel it helps with my understanding. Where I see that it's going up, I know that it's a positive gradient. It is accelerating because the velocity become a bigger value, from 0 become 10, right? So it's going to be a positive value. Okay, you don't have to write positive. And then what is the y distance? Y distance 10. What is the x distance? 5. So just 10 over 5. Y distance over x distance. Okay, don't terbalik all. Y first, remember. The vertical one first, over the horizontal one. So that's 2 meters per second. Always double check your plus minus sign. Okay, if you really feel that your plus minus sign, you always forget, just go and do the y2 minus y1. Okay, just go and do that. Okay, don't have to follow mine, just go and do that. Right, do what's best for you. So 2 meter, oh, sorry. Apa saya buat ni? Okay, sorry. This one is acceleration, my bad. And the unit is meter per second squared. Okay, correction. Acceleration, Okay, part 2. Now I want to find out the acceleration at the 7 second. If the question asks you for the acceleration at the 7 second, at the 6 second, at the 8 or 9 second, it's all going to be the same value because same straight line. Okay, same straight line. It's just one straight line. This one got acceleration, no, actually. 0. Yes, Jashan said 0. Yes, very good. So it's just going to be 0. No, not accelerating. Accelerate means what? Become faster, get faster. If you stay at 10 meters per second, you're driving 10 meters per second, constant speed, 0 acceleration, not getting any faster. Therefore, A is just 0. Okay, A is just 0. And you can see that the gradient, if you go and find what is the y distance, 0. There's no increment in the height. The x distance, 5. So 0 over 5, still 0. Okay, so don't need to calculate. Okay, with that knowledge that you have now, that you are going to find gradient, you know when to put plus, minus, and so on. Can you guys try for part 3, part 4, part 5? Okay, I give you all a bit of time. Quickly go and find out the gradient value, which is the acceleration. Okay, which is the acceleration. So all the straight lines have the same gradient. Yes, Charisha, all straight lines have the same gradient. Any straight line that looks the same, the gradient value is the same. You learn in Form 3 something called y equals to mx plus c, right? M stands for gradient. By definition, right, what does gradient mean? Okay, what does gradient mean? Gradient actually means, this one extra knowledge, don't need to write. How steep a line is. A line, so the steepness of this line. If a person, if it's the same line, the person standing here, it's all the same steepness. Okay, that's why same straight line will have the same gradient. Unless you change it, then it's a different gradient. But if it's the same straight line, same gradient. Remember that. Okay, very good. Okay. Okay. I'll do my version. Continue doing if you are not done. So at 12 seconds, that means it's somewhere here. This one is 5. This one is 4. Negative 5/4. Okay. Then careful, negative, decelerating. This part slowing down. I got 13 by doing 18 minus 5. I got 4 by doing 18 minus 14. Okay, negative gradient again. Put in negative yourself. Y distance is 18. X distance is 6. Okay. Remember to just do y2 minus y1 over x2 minus x1. If you don't like this, okay, it's fine because I've been teaching this way, but I'm not sure. And it's different from one batch to another batch. One like there is maybe a senior who is okay with this kind of things. Maybe you guys don't really like this because maybe when you learn this in maths, you didn't learn it very properly, or I'm not sure. Okay, so just do what suits you. I'm giving you options. Remember, also will get same marks one. So it's really finding the thing that you are comfortable with. Don't have to follow my way. Both ways also can. Okay. And that is 2.3. Example 2.3, done. Okay, so again, the whole purpose of this question is, I think this is a very good question. If we ever suddenly get confused or unsure when we want to do revision, right? Maybe a few months later, you want to come back and revise this and you're not too sure what you're learning in this topic. I think example 2.3 is a very good one to tell you that if I have a V graph, I want to find S, find area. I got a V graph, I want to find A, find gradient. Okay, so that's why, right, in exam, if they ask a longer question from this graph, this kind of graph question, right, usually they like to give you V graph. Why? Because they can ask you both sides. They can ask you to find area also can, ask you to find gradient also can, right? So they can ask both left and right also can. Okay, I move on. Everybody okay? No questions? Can I? All right. Okay, back to this question. Sorry, just now I don't know what I was thinking. Okay, 2.4. The figure shows the velocity time graph for the car traveling to east, which is the right side, I said. Opposite direction, that's west. Okay, what is meant by velocity? So a lot of students, they will get very frightened now when they see this kind of definition question. But I want you to just know that you don't have to say word by word. Okay, that's not what you are aiming for. Try to think back and put out all the important points. Okay, velocity. Think of the formula lah. Think of the formula. we have displacement over time, displacement over time. And if your memory is a bit better, you remember that I say before many times, if you have over time, usually we can say rate of change of something, right? So velocity is just the rate of change of displacement. Okay, rate of change of displacement, right? If you notice, right, when I teach you something, I don't just vomit all the answers out for you. I want you to try to think with me. And I hope that it works, lah. Right? I hope that it works. And in exam, you think, okay, yes, Mr. Brian said, okay, I'm going to think about the formula. They ask me this, then I think like, okay, displacement, and then there's time, and there's rate of change of displacement, right? So hopefully, if you don't remember, you can think of what I said and try to figure something out. And hopefully you get it right. Okay. And part B. State the type of motion of the car during the first 4 seconds. Okay, this is a velocity time graph. Okay, velocity time graph. You can see in the first 4 seconds. Anybody want to say answer not? Velocity graph, huh? So the velocity go up like that means no one? Bradley said acceleration. Yes, very good, Bradley. You're right. Oh, Teresa, calculate for me some more. Hold on. Yes, correct. But I want to state the type. The type. I don't want the value yet. Okay, don't want the value. So Teresa, you don't have to calculate yet. They might ask us to calculate later, but that's not what I want. So read the question carefully. We want just state what type. Is it accelerating? So you can say, I would say constant acceleration, not just acceleration, but constant acceleration, or uniform also can. How do I know it's accelerating? Because it is getting faster. The speed, the velocity from 0 become 25, right? So it is getting faster, accelerating. How do I know it's consistent? Constant, because it is the same straight line. The acceleration value, like Trisha calculated for me, 6.25, is going to be the same value the whole time. I think the gradient value is going to be the same value the whole time. But see, on the figure marked with R, the region with 0 acceleration. Okay, hold on. Jashan asked me uniform velocity increase uniformly. Yes, can also. Okay, velocity increases uniformly, also can. Okay, I prefer constant acceleration actually, if can. Yeah, just because it feels like you have actually analyzed the graph a bit and even found out that the gradient is a constant value. That's why you know constant acceleration. Uniform velocity means it's stagnant, does not change. Yes, that's right. Jashan asked me if uniform velocity means that it doesn't change. Yes, he is right. So if you say uniform velocity, then it's wrong. Remember, we went through this before. Uniform velocity means a constant velocity value. That means the velocity is just one line like that, like something like this. Okay, but if you say increase uniformly, that means it increase consistently, constantly. Okay. Mark with R the region with 0 acceleration. 0 acceleration. That means this part, yes, 4 to 12. Okay, so I think you guys can take your pencil and then you just slightly shade this part and you call it R. So this is the region from 4 to 12 that you have 0 acceleration. Okay, 0 acceleration. The velocity is not increasing, not speeding up. 0 acceleration. Okay, or you can find the line which has 0 gradient. Okay, So part C don't need to write. Part D, how long does the car travel with constant velocity? Well, that is just from 4 seconds to 12 seconds. Constant velocity. Okay. The car actually traveled at a constant velocity for 8 seconds from 4 to 12. So C and D actually is asking the same thing in a different way only. Referring to the graph, calculate the distance and displacement of the car from point O when it arrives at point T. Okay, distance and displacement. Okay, distance and displacement. So here is when it becomes a bit tricky. Okay, a bit tricky, and I can foresee some of you start to confuse a bit. So just pay attention to this part, especially the displacement later. To find out the distance for the whole journey, we would first find out what is the area for this trapezium. How come I know for sure it's going to be area? What graph do you have? Remember, I tell you can always write this thing at the top for this kind of question. Okay, you have velocity graph and people ask you to find out the distance. What do you do? Find area. Okay, so I'm going to find the area of that part. I'm also going to find out the area of this triangle. Okay, so it's a trapezium plus triangle situation. Okay, so the distance is actually 1/2 the parallel sides. A trapezium has got 4 sides. Find out the 2 sides which are same one, parallel one, these 2. Okay, here is 16. 4 to 12 here is 8 lah. Just now we calculated it. Okay, from 4 to 12 is 8. What is the height? 25. Okay, so it's something like that, huh? 16, 8, and then the height is 25. Okay, so 8 plus 16 times 25. Can I do one shot? The orange color part also. Okay, we try. So the base is 16 to 28. Calculator lah. 28 minus 16. That is 12. Here, here's 25. Here's 25. Okay, so the area is 1/2 times base times height. Okay, 1/2 times base times height. So you calculate this part. This is the green color part. And you calculate this orange color part. Okay, to find out how much the car has traveled. And that would be 300 meters here. And also 150 meters here. Okay, 300 meters and 150 meters. So in total, the distance is 450 meters. That is the distance. Okay, that is the distance. Distance I feel should be okay. So just make sure your area, you can get it right. And then don't use negative 25 as the value. You use the height, you use positive value. Because height shouldn't be a negative value, right? Okay. Before you do displacement, right? Okay, before you do displacement, maybe I want you guys to read again the question at the start there. They say that the car traveled to the east and then traveled in the opposite direction for a while. Okay, in the opposite direction for a while. So if you were to draw out, right, the situation actually goes like this. You start here, you go some distance, and then you come back up. Okay, you go some distance, and then you come back. So the displacement, by definition, is the shortest distance from the starting point to the end point, right? Okay, I hope you all listen this sentence until very sian already. That would mean that it's better embedded in your brain, I hope. Okay, from the starting point to the end point, right? If exam asks you, hopefully you can vomit out the same thing I keep saying. Okay, starting point to the end point. So you have to understand that it changed direction, which then mean, right, your displacement is equals to 300 meters minus 150 meters. How come need to minus? At first, you go 300 meters. That's the green color part. We calculated that already. Okay, I think I don't have to write out the formula one more time, right? That's 300. And then after that, you go backwards. You go backwards for 150 meters. Okay? That would mean that the displacement is 150 meters only. Okay, 150 meters only. Which all is going to make sense. Why? Because at the start, I keep telling you guys that the positive velocity means it's traveling to the right, for example, which is to the east for this case. Negative velocity means it's traveling in the opposite direction. For this case, it's to the west, to the right side. Okay, so maybe you guys can add on in your diagram here, right, that this part, anything that is a positive velocity, that means above the x-axis, is moving to the west. To the east, my bad, to the east. East is right side, to the east, right side. The whole thing here is to the west one, left side. Okay, so the moment, right, you see that it goes down like that, that means it's, okay, start to go in the opposite direction already. Okay, start to go in the opposite direction already. If don't understand this displacement one, why I minus, please let me know. Okay. And there's one more very important point, right, which I think you guys can help you guys to understand velocity graph better, which is this little point here, point R. Do you guys know that this point is the point where it changed direction? Okay, when the velocity is equals to 0, it could mean that it changed direction. I give you a very good example that you probably have, which you will probably understand quite well because we have done it last week. Remember I told you guys that when we did the question where you throw a stone, go up, and then it reached the highest point, before it comes down, right, at this very highest point here, the velocity is equals to 0 because it slows down, and then it must stop for a short moment and then come down. Okay, it's just a split second kind of thing. So at that highest point, before it changes direction, the velocity is equals to 0. Okay, the velocity is equals to 0. That's why for anything that you change direction, right, even if you go a car, go here, and then suddenly you want to turn back. Before you want to turn back, you have to stop first and then turn back. Okay, you have to stop first and then turn back. It could happen in like a very, very short instant, but you actually have to stop very quickly first before you can turn back for anything at all. Okay, you have to stop very quickly and turn back. Okay, we are talking about any motion that is movement in a straight line now. Okay, movement in a straight line. We're not talking about like your car go and then go one circle and then come back. Right? That one different story. That one go in a circle, right? We're talking about in a straight line. Okay, which is what this chapter is all about. Chapter 2 is linear motion. Okay, surprisingly, no questions at all. Does that mean that it is okay? Jiahui asked me, if stop at 0, we just minus. Yes, you are right. Okay, so anytime when you see there's a change suddenly at this v equals to 0, it means that it starts to change direction already. Okay, that means you're going forward, and then go backwards. Okay. In this case, it's go to the east and then go back to the west. In the question, actually, they also state for you already. It's just that I feel a lot of students will overlook this statement. Okay, the graph tell you one time, in the up there also tell you another time. Cherisha. Yeah, Cherisha, I got 150, right? Displacement is final minus initial position. No, displacement is not final minus, displacement is the shortest distance from the starting point to the end point. Okay, this at first you move to the right for 300 meters, and then you move to the left for 150, right? So the position, displacement is position. The position from the starting point is how far away? How far is it from the starting point? 150 meters, right? Right? 150 meters, right? Yeah, so that's the displacement. Displacement means, okay, you can think of it as displacement is position. That's why I always tell you. Also, displacement is the shortest distance from the starting point. Okay, from the starting point. So if your starting point is here, and then at the end, your, okay, good. At the end, your car, let's say, is here. What does that mean? That means that your displacement is negative 10 already. Okay, 10 meters to the left. So let's say your starting position is here. Your car end up here. And then this is 8. Then that means this is positive 8 meters. Okay? That's why you see I keep saying it's like a position, like coordinates, right? If you understand displacement in this way, it will help you. It will help you a lot. And now everybody, we go to part F. Hence, calculate the average speed and average velocity for the entire journey. So since we have calculated the total distance and the total time, we can go and find out what is the average speed, okay, which is 450 meters divided by the total time. You look at the graph, go up, go down, go up, go down, and then eventually stop at 28 seconds. Calculator, type, you will get 16 point, maybe I just do 2 decimal, 07, or 16.1 also can. That's good enough. All right, and then average velocity. The total displacement is 150 meters. Total time is 28 seconds. This one I put 2 decimal places, but both also at least 3 significant figure. I feel that's quite good already. And that's it. That is 2.4. These questions, I feel, now that I've explained, right, they're going to be really good questions for you to revise back whenever you need to. Okay. I was once a student like you guys are. For physics, when I revise back and stuff, right, I always also look back at the previous questions that I did in tuition, for example, or did in school. And then if I feel like I can do, I understand what I did before that. And right now also I understand, my memory is fresh. Before exam, I go for exam, I usually will be okay, right? So don't always need to find for new questions to do. If you understand that all your basic stuff, every chapter, your memory is fresh before exam. You go to exam and do, it should be okay, right? And I want to clear a misconception about physics. Your physics is not a maths subject. Physics is not a maths subject, so you shouldn't expect your SPM paper to have a lot of calculation. 15% only, maximum, in the entire physics paper calculation. 15% maximum. Sometimes less, sometimes slightly more, but around 15% only. The rest all theory. That means you need to explain, write in words, all that kind of stuff. That's why physics is a subject of understanding what is going on. Not, well, knowing how to do the calculation is important because that helps you to understand. Okay, that helps you to understand. But don't think like all the question is going to be calculation. Okay, that's not how physics is. Can I move on? Okay, can 2.5. Can Kiruna, can Trisha. 2.5. The diagram shows the velocity time graph for a car which is traveling 90 seconds before it comes to a stop. Okay, so let's look at this velocity time graph and maybe let's not rush into it this time like the previous one. Now that you have a better understanding that anything that is above a velocity graph means is means is moving in let's say to the right. This means that there is no change in direction. Okay, there is no change in direction because there is no graph down here on the left like that. Okay, they didn't draw any graph like that down here. So it's all going in one way like that only, and then it stops there. Okay, so now you understand better how it works. Huh? So different graphs got different traits. Okay, all the questions I put here is carefully thought of already lah. I don't just simply take any questions and put down, right? It's carefully thought of so that you understand the important traits for each question. Okay, the diagram shows the velocity time graph for each car, for a car which is traveling 90 seconds. So in part A, they ask us to calculate the acceleration for the car in the first 50 seconds. I am pretty sure everybody should be able to do this. Okay, if unsure, write down SVA, circle the one that you have. If they ask to find the acceleration gradient, okay? So this is a positive gradient. That means it's speeding up, getting faster. The y distance is 25. The x distance is 50, okay? 50. Part B, actually, they are asking for this part. What is the deceleration? Because there's only 3 sections of this graph, right? Only this part has deceleration. Huh? So if you just did the y distance over x distance, then you would get the deceleration straight away. But if you do like a equals to negative, because you know it's slowing down, the y distance is 25, x distance is 10. Okay, then the value that you will get, right, is acceleration. No? But remember, if they want deceleration, you can not write the negative. You should not write the negative. Because deceleration itself, we've done this many times, already carries the meaning of a negative value. Okay, negative value. Okay, calculate the total distance traveled. There's a fast way. There's a fast way to do this because this whole big thing is just a trapezium. Okay, this whole big thing is just a trapezium. But can I choose to do this slowly? Okay, can I choose to do this slowly? I will say why later, but for now you just go together with my flow. Okay, there's a reason why I want to do slowly so that I don't have to do double work later. Okay, so this part, I'm gonna do this part, blue color one. Okay, and then I'm going to do the orange color one. And then I'm going to do the green color one separately. Okay. So later I'll tell you why I do separately. You can also do one shot as a big trapezium. Okay, because this is a trapezium. So the total distance is equals to, part by part, we have 1 over 2 times the base times the height. Okay. This one is the blue color triangle at the first part. And then let's deal with the orange part. That is just a rectangle. Okay, so we find out what is the base, what is the height? 30, 25. Last part, the green color triangle. 1 over 2 times base times height. Okay. Again, like I said, you could do the half times, treat it as a big trapezium, then the working will look like this. 90 and 30 times 25. Yeah. Because here is 90, here is 30, here is 25. You can get the answer straight away. Okay, so I'm going to calculate out one by one. It'd be great if you have different color highlighter and you can highlight these 3 different parts. Don't have also never mind, huh? Don't worry. 750. And then last one. Okay, if you did this, you are going to get 1,500 meters. So they'll both give you the same marks, but I'm preparing you for part E later. For part E later. Okay. Yeah, Cherisha asked to find both displacement or distance is area under the graph. Yeah, correct. Okay, because displacement and distance, they have similar meaning. Then for displacement, you just have to double check. You see whether or not you got go in a opposite direction. So if you go and then you come back, you must always remember to minus. Okay, you go and come back, you must always remember to minus. That's the only difference for displacement. Both also is area under the graph. Okay, welcome. Part D, sketch an acceleration time graph. All right, so in part A and part B, we actually have already calculated what is the acceleration for this straight line. Okay, it is actually 0.5 meter per second squared, sorry. And then here, what is the velocity? Flat line, right? I got V, and now I want to sketch the A graph. So I'm looking out for all the gradients only. For this part is 0 meter per second squared, because the velocity is just a fixed value, constant velocity, 0 acceleration. Okay, constant velocity meaning 0 acceleration, fixed value for your velocity. The last part, the acceleration is negative 2.5 meter per second squared, because it's slowing down. So you can imagine, right, because my acceleration is just these 3 values, when you draw, right, leave some space down there because we have negative 2.5 there to put So you have the 0.5, you have 0, and then you have negative 2.5. Okay, so from 0 to 50 seconds, the acceleration just constant, fixed value only. Okay, fixed value only. Right, and then from 50 to 80 seconds, maybe I should use another color. Okay, from 50 to 80 seconds, the acceleration is just 0 because it's not getting faster. It's just a constant velocity. And then the last part, it is a negative 2.5 down here. Okay, from 80 to 90. You want, right? You can actually connect the graph like that. Okay, so the graph is like a staircase like that. From 0.5, that means it's actually speeding up first, and then it maintains the speed, and then it slow down. Okay, slow down, and then eventually stops. Okay, so acceleration time graph. Usually acceleration graph looks like a staircase. Okay, displacement time graph is when it gets more interesting. Okay, because the displacement for the blue color part, orange color part, and green color part, they are all different. Like the way they increase, right, in terms of their distance is all different. Okay, it's all different. So for this graph, because you're all moving in just one direction, you're not going backwards, so you won't have any negative displacement. Huh? Okay, the displacement is all positive only because they didn't change direction. There isn't a negative velocity. Negative velocity means you change direction. It's all positive velocity, you see? 25 and then come down, become 0. So it's never reached the bottom part. So it's all going to move forward only. So you are going to expect your graph, right, to not have any negative displacement. Huh? That means it didn't move past the 0 mark. Okay, so I'm going to prepare this graph first. At first, you have 0 and then 50, let's say it's here. And then I got 80, let's say it's here, and then 90. Okay, just agak-agak. Huh? And then, right, at first, you travel 625 meters. Okay, at first you travel this much. So will be at this point. Okay, later only we see how we get from 0 to 50. And then after that, on top of 625, you see the orange color part earlier, the orange color part from 50 to 80 seconds, you travel another 750 meters. Another 750 meters. So you have to go and plus 750 on top of 625. Okay, so the car travel for 625 meters already, and then continue 750. So in total, it has now gone up to 1375. Who don't know how I got 1375? Please let me know. Okay, so from 50 to 80, increased by 750 meters, the orange color one. The green color part, color part, I'm referring to part C as well. The green color part is 125 meters. In that 10 seconds alone, although I know it's slowing down, but it's still traveling a certain distance, it's going to move forward some more. Okay, at first you move forward 625 meters, continue move forward 750, then continue move forward 125 again. That would mean you need to plus 125. So 1375 plus 125. At last, you will reach the furthest distance of 1,500. Okay, Jawi asked me how I got 1375. Okay, no problem. So at first, you travel forward. This is the starting point. You travel forward for 625 meters. Okay, that is in 50 seconds. And then you travel another 750 seconds, right? Look at the here, orange color, the red color part. Here. Okay, travel another 750. So in total, how much is that already? 625 plus 750. That's how I get 1375. Okay, and then in the next 10 seconds, you travel another 125. So in total, 1375 plus another 125. Okay, which makes sense now because just now we calculated that our total distance is 1500 meters as well. So at last, you should be able to add until you reach that 1500. Can I, Javi? Okay, welcome. Got question? You all just ask, please. Is it me or this class is getting more and more quiet? Okay, I hope you guys are just more and more focused and not more and more distracted. Okay, so you have 0 to 50 seconds, 0 to 50 seconds. And we'll think how to connect them, how to connect them. The easiest one, right, is actually the orange color part. Okay, from 50 seconds to 80 seconds there, right, the distance is increasing consistently. Okay, the distance is increasing consistently, right? So actually, for that part, it will look something like this. Okay, when I say consistently, it's because it is a rectangle. It is a rectangle. So every time you add a certain distance, right? Let's say 50 to 60, this distance, and then you add on this distance, add on this distance. It is the same value on each block. Okay, you're adding up the distance consistently. Okay, that's how you reach from 50 to 80. But when it's in front here, let's say this is 10, this is 20, this is 30. Do you guys agree that, I need your attention this one now. Do you guys agree that the first area is smaller than the second area? And then it keeps getting bigger and bigger and bigger, right? The area keeps getting bigger and bigger. That means you're increasing at a faster and faster and faster rate. Okay, that's why acceleration, if you look back at the first part of your this topic, when it's acceleration, okay, when it's accelerating, the graph will actually go up. At first, it's flat one. At first, it's flat. That means how it increases is not very drastic. And then it gets more and more drastic. That's when it's getting more and more steep. Okay, steeper and steeper and steeper. All right. Since I'm here, I talk about deceleration as well. So deceleration, right? If it's decelerating, at first it's very steep, at first it's very drastic, and then it slowly smoothen out, and then it flattens, slowly become not as drastic anymore. Okay, so you must remember that got acceleration usually does not mean that it is a straight liner. So you have three possibilities only how you connect, how you go from V to S graph. Okay, you can either connect straight, you can connect curve up like that, or you can connect curve down like that. Okay, so curve go up means at first it's very sharp and then it flattens out. Flattens out, slow down. Okay, this means slowly slow down. Like that means it is constant increment in your velocity. Okay, like that means zero acceleration. But if it's like that, becomes sharper and sharper at the end, speed up, increase in acceleration. Okay, so for this case, our graph would look something like this. It curves up. How you curve up doesn't matter as long as it doesn't look like a straight line, then can already and can see curve up. The behind part is straighter a bit. At first, it's a bit flatter. So which means the behind part, right, will be like this. Okay, will flatten out. How curvy you do, never mind. Just make sure it doesn't look like a straight line. You see yourself if you were the examiner and you want to mark your graph, it doesn't look like a straight line, then okay already. I can see curve up, then it's fine already. How curve you do is doesn't matter. Okay, so must be a curve, straight line curve. Which makes sense on, huh? You can always double check back one. It will all link back together. Go and try to find out the gradient of these three parts. Am I right that the gradient of this part is just a fixed value? Okay, it's just a fixed value. You look back at the graph from 50 to 80 seconds, the velocity is just a fixed value from at 25 meters per second. Okay, from the original graph there. Just a fixed value because the gradient is just a fixed value. So I'm just double checking back. What about the gradient for this part? Okay, the gradient or the velocity keep on increasing. Okay, the gradient or the velocity keep on increasing from 0 increase until 25. Right, that's why it becomes sharper, the curve. If it's a straight line, then it's going to be a fixed value already, the velocity, but it's not a fixed value, right? So yeah, you can always double check like that. Okay, so in exam, right, if especially, I think this is the most confusing graph of all. Okay, and if you get confused, try to practice this back again. Okay, so it's usually the velocity to displacement graph. You do what I do first, you put down all the points and I get ready everything first. Then later on, I just need to see how to connect. Is it going to be a straight line? Because I clearly know that it has traveled a certain distance. Or is it going to be a curve like that or curve like that? Then you ask yourself a simple question. Or you can just remember accelerate is curve upwards like that. Okay, this is for displacement graph. Don't draw the wrong graph. Then constant velocity, cause constant gradient. And then flattens out, that means decelerate. Do you all have any problem with this? Is this hard? Yes, this is definitely one of the hardest graphs. Okay, but you have to know now. Again, in the first part, 2.2 there already put down for you. If confused, you look through that one again. Okay. Charisha asked me, does the gradient change? Which part? For the first part and the last part, yes, the gradient changes. If it's a curve, that means your gradient is not a fixed value. Straight line, this gradient or the velocity is fixed. Okay, this one means what? The gradient at here looks something like that one. Okay, The gradient at here looks something like that one. The gradient at here looks something like that one. Do you see the way the red color line slants? I'm drawing at that point only. I'm exaggerating that point and making it like a long line. But can you see that at first it's flat and then it curves up and then it curves up some more? That means that your gradient is getting greater and greater and greater. It's getting steeper and steeper and steeper, sharper and sharper. How to know when you need to use a curve line? When it's acceleration, Teresa asked me when I know it's a curve. When it's acceleration or deceleration, it's going to be a curve. Okay, you look back at this one, or else it won't link together, or else it won't make sense. Right? Or else it won't make sense. Acceleration is 0. That means if it's not accelerating, this one automatically will be like this. If it's accelerating, that means the velocity increases. Your gradient must be sharper and sharper and sharper and sharper. From flat becomes steep. The gradient is increasing. Then only you will have a velocity that keep on increasing. Because my gradient increase, then gradient means what? Gradient for the displacement graph means the velocity, right? Increase, increase, increase. Okay, so you see this one? Velocity, will it increase or not? No, it's just one fixed value. That's why it's just here like that. Okay, let's say the gradient is 5, for example. That means gradient means the velocity. That means here also is 5. Understand? So this one doesn't change, but this one keep on changing the gradient. I have some students, right? How they remember it, right, is by remember where the placement of, they actually have this, some people, they remember by diagrams. They remember by diagrams. And some people, they remember by words. Okay, I'm a diagram person also. Like, if I need anything, right, I would imagine this piece of paper. I know it's a bit sounds a bit crazy, but I would usually imagine this paper. And for example, I know like, okay, this graph is here, and then behind of it is this, and then this acceleration is 0, that kind of stuff. So like if my velocity is going up, I would think back, but this one is based on memory, not so much on understanding, right? So if you understand at this point what I'm explaining, but it takes a really long time for you to figure it out in exam, then maybe remembering it and understanding it together would really help you a lot. Okay, yeah. Different people will have different ways of remembering. Yeah, I'll leave that to you. Okay, last one. Second last one. No problem, if got problem, go through a bit yourself. WhatsApp me if you need help. Okay. Example 2.6, a car moves from rest with an acceleration of 2 meters per second squared for 5 seconds. It then moves with a constant velocity for 10 seconds. Calculate the uniform velocity traveled by the car. Okay, let's try to draw out this situation first. With a diagram, usually it's a bit easier. From rest, and then acceleration is 2 meters per second squared, travel for 5 seconds. It then moves with a constant velocity. Then from here, it's going to move with a constant velocity for 10 seconds. Okay, so it looks something like that. So at first it speed up, and then after that it reaches a certain velocity, and then it continues that velocity. So the velocity throughout here, right, from here to here, in the last 10 seconds, is all the same. Okay, the velocity is constant. Calculate the uniform velocity traveled by the car. That means we want to know the velocity of this red color part. Okay, we want to know what's the velocity of this red color part. Okay, I suggest you guys write the A down here if you can, because later we have some graph to draw. I think that will take up some space on the right side here. Okay, so uniform velocity. Do you realize that as I write all this stuff, right, it looks something like the linear motion equation question, right? Because you write, and then you got so many things come up, right? So I told you before, you don't really have to know whether or not this one is a linear motion equation question. If you are able to write out this many things, then usually it is. Okay, if you need it lah, if you need the equation to find out something, then usually you can. Okay, so we want to look for the uniform velocity. The question here is, am I right that the velocity here, the final velocity here, is going to be that same velocity throughout the last 10 seconds? Okay, that velocity there is going to be the same throughout the last 10 seconds. Yeah, Trisha said yes. Yes, okay. Yeah, right? Because I told you that the last part is going to reach a certain velocity and it keep that same velocity. So we're going to do linear motion equation again. And I don't want S. So you can go back to your equation. Okay, you can just flip to this, go and find out this equation. Okay, let me copy this. I don't want S. So refer to this, and don't want S, don't want S, don't want S means that it's here. Okay, since I want to look for the final velocity, I'll take this. U is 0, A is 2, T is 5. That means 5 seconds later, if I'm accelerating for 2 meters per second squared, the velocity will go from 0 until 10. And then after that, I'm going to keep that same velocity 10 meters per second for the next 10 seconds. Okay, so I'm going to keep that same velocity 10 meters per second, 10 meters per second, constant speed, constant velocity. All right, so yeah. Okay, can. So I'm only, for part A, I'm considering only the first part. Remember, you can chop your journey into different sections. So for this section only, the final velocity is that. Okay, then we're going to draw a graph in part B. Sketch the velocity time graph to represent the motion of the car. Okay, velocity time graph. Well, we know the velocity at the start is 0, and then after that becomes 10. So at first is 0, and then after that it becomes 10. And that took 5 seconds. That took 5 seconds. And then after that, it's going to stay 10-second constant velocity for the next 10 more seconds. So this one, you're going to write 15. Please don't write 10. Okay, another 10 seconds. So 5 seconds plus another 10 seconds. That will be 15. Your graph at the end part is going to look like this. Okay, because it's just constant velocity. But if you are one of those students who suddenly, after doing the previous question, is uncertain whether or not are you going to draw a curve or a straight line? Okay, well, this is the time. For those of you who know the answer, very good, good for you, the first part. For those of you who suddenly is unsure, well, let's see. The first part is constant acceleration. Okay, constant acceleration. The gradient of this is what? Acceleration. When is a gradient a fixed value? When it's just a straight line. Can it be a curve or not? Cannot. Because if it's a curve, the gradient is not a fixed value anymore. Okay? They told you that the velocity for the first part is 2 ma. Correct? 2 meters per second squared. That's why it cannot be a curve. Okay, so if you confused suddenly, can it be a curve or not? Then no, this is not a curve, constant acceleration. Okay. Part C, calculate the distance traveled by the car with uniform velocity. Okay, during the uniform velocity part, we want to calculate the distance traveled. That would be just the rectangle here, right? Okay. If you have a V graph and you want to look for the distance, find the area. Remember SVA? So you see now every question will have this one. And as I draw the graph also, I keep testing on my understanding on whether or not I understand that something is a gradient of another thing, that kind of stuff, right? If I'm unsure whether is it a curve and stuff like that, I'll start to think about gradient again, right? Straight line, that means gradient is a fixed value. If it's a curve, then gradient is not a fixed value. Okay, that means it's increasing or decreasing. Okay, so for part C, just distance, that would be ten times 10. Huh? So this is for the green color part. Okay, 10 meters, 10 times 10, 100 meters. Part D, sketch the displacement time graph to represent the motion of the car. So I also need to know what is the distance traveled in this first part, this triangle part, right? And that's going to be, so this is for, maybe I put down, this is for 5 to 15 seconds. Okay, that's the green color part. But if it's for 0 to 5 seconds, right, the distance, it will be a triangle, right? Area of a triangle. Okay, area of a triangle, 25 meters. And that is the blue color part. Okay, so at first travel for 25 meters and then after that travel another 100 meters. That is your distance. So we can draw our displacement time graph already. I want to ask you guys something, right? Is there a change in direction? Did this car move and then reverse back different direction? No, right? Yeah, Teresa said no. Yeah, don't have, because the velocity all is a positive value. You see the whole graph is floating on top. Floating on top means what? Same direction. Okay, never move backward. So that means don't have, never move backward. That means usually means don't have negative displacement. Okay, this graph won't be so complicated. There's only two parts. There's the blue part and there's the green part. All right, so for the blue color part, okay, maybe I get ready everything like just now again. At first is 0. We have 5 seconds and then 15 seconds. 5 seconds later, it has traveled 25 meters. And then from the 5th second to the 15th second, it has traveled another 100 meters. So you need to add on top of that 100, right? So it's going to be 125 then. So this one is here, this value. This one is here. So our question is how to connect them together, right? At first from 0 meter travel until 5 meters, travel until 25 meters, 25 meter travel until 125 meter. So the easy one is the back part, because the back part is a straight line. How come I know it's a straight line? Because the velocity is just fixed at 10. Okay, the velocity is just fixed at 10. Right? You see how they increase the area? Each time the area is the same one. So your increment is consistent one. But you see how much they increase, right? This area at first very small from in the first second, and then in the second, Second, the area suddenly jump up, become bigger already. And then the jump is going to be more and more dramatic. It's going to increase more and more, right? So this is when we know the graph is going to be a curve and it's going to be sharper and sharper. That means the increment is going to be more and more dramatic. That's why it's going to go up like that. That's why the graph becomes sharper. At first it's flat and then it becomes sharper, right? And again, why is it a curve? Because there is an acceleration and behind there is no acceleration. Okay, so whatever we do, it all links back to the first big table that you see in the topic 2.2 there. Okay. So the Kiruna asked the curve line is only for displacement graph. If they ask you to draw, right, then yes, the curve is usually only for displacement graph if they ask you to draw. Because if you have a curve line with velocity graph, it means that your acceleration keep on changing. Okay, your acceleration keep on changing, but we never really learned that. We never really learned how to draw that. It's not really covered in your syllabus. Okay, it's not really covered in your syllabus. So if they ask you to draw, they won't. So you have asked me a very good question because now I can give you a velocity graph and give you a curve and now ask you whether or not you're able to state for me the type of motion, right? So they won't ask you to draw, but they can give to you and ask you to state the type of motion, right? That's why I'm going to put down, that's why I purposely put down this one more last example, okay? Although we don't need to know how to draw a curve velocity, but we need to know what it means, okay? We need to know what it means. Okay, so that is going to be the last question or last example for this topic 2.2. Everybody ready? I want to finish that up and then we can go on. Okay. Right. So before I do this question, right, I need you guys to know that they won't ask you to draw a curve for velocity graph. They won't ask you to draw that. Okay. Maybe they might ask this in objective question. You might see later on in some of your objective question, maybe they ask you this thing also, right? So let's read through the question first. The figure shows how the velocity of a particle changes with time. For each section of the graph, describe the motion of the particle. In this question, what we want you to do, or what we want from you, is only this. Okay, maybe you can just point out. The highlight of this question is only to know how to read the gradient value. Okay, to understand the gradient of each type of lines. Okay, to understand the gradient of each type of lines. For example, from O to A, the first section of this graph, the velocity is increasing. The line is a straight line like that. Okay, this is called what? Constant acceleration. Correct? Velocity increase, constant acceleration. I know some of you may say velocity is increasing uniformly. Same meaning. Constant acceleration is a bit better. Okay, so this is talking about how to analyze the gradient, right? That's our whole purpose for this question. A to B. Velocity is at a fixed value. Zero acceleration. Okay, you have constant velocity or zero acceleration. Okay, the speed remain at the same place. Velocity remain at the same place. From B to C, do you see that it speeds up? It goes up, it speeds up. So it's confirmed an acceleration, but what type of acceleration is it? The gradient is curving upwards. It's going to be more and more dramatic. At first, it's flat and curve up. Okay, flat and curve up means what? increasing acceleration. How I know it's increasing acceleration? Because this part is increasing gradient. Right? I told you it's all about the gradient. Increasing gradient. The gradient is curving upwards. The gradient value is getting greater and greater and greater. What is the meaning of gradient in this case here for a velocity graph? Gradient means acceleration. Same meaning, okay? And then C to D. Oh, sorry, Charisha, I didn't see your message earlier. Yeah, constant velocity just now. C to D. Okay, I want to ask you guys, right? C to D, is it still getting faster? Is the velocity increasing? Is it becoming faster? Yeah, Jaden said decreasing velocity. Very good. No. Yeah, decreasing acceleration. You're right. Not velocity, not velocity. The velocity is still increasing. That means I'm still speeding up. As long as your velocity is still increasing, that means it's still speeding up. Okay? Just remember, anything that slants like that, all positive gradient one. Anything that slants this way is negative gradient. Okay, cost go down, this one go up. Therefore, this is called decreasing acceleration. Okay, it is accelerating, it is getting faster, but the rate of it getting faster is decreasing. Okay, what does that mean? That means that maybe at first the acceleration is 5. And then after that, the acceleration is 3. And then after that, the acceleration is 1. I know that as long as my acceleration value is positive, it means I'm getting faster. It means I'm getting faster. It's just that how much I'm getting faster, that value will become smaller and smaller and smaller, decreasing. Okay, so positive acceleration, ask yourself, means what? Getting faster still. Huh? Okay, the graph becomes flatter. What about D to E? Huh? Like that, go down already. You see the speed, the velocity go down. Constantly go down, right? It's called constant deceleration. Okay, so this is really a very good test on your understanding on gradients. Constant deceleration. This one, another deceleration. They're all decelerating. The velocity all keep dropping now. Okay, just how are we dropping? This one is decelerate also, but this one is getting flatter. Do you see that the curve get flatter? Flatter. Flatter means what? Decreasing deceleration. Yes, very good, great, Jaden. Last part, F to G. Also a deceleration because it's going down, but it's increasing. You're right. How come? Because it is getting more and more dramatic. At first, it's flat, and then it gets sharp. Okay, that means it goes down really fast. It decelerates really quickly. So you can see, right, at the start, actually, you already know that all this all accelerate. Acceleration, acceleration, acceleration. All this, since it's sloping down, is decelerate, decelerate, decelerate. That's why you have all this bunch of deceleration here. And most of it here is accelerate, right? Yeah, just looking at the slope, you will know it's accelerate or decelerate. But then how it curves up, that tells you whether it's increase, decrease, or constant. Okay, like I said, will they ask you to draw this kind of curvy V graph? No, but they can give you a curvy V graph. Okay, this is a very extreme question. They won't ask you this kind of question. Okay, this is a very extreme question. Maybe the question will ask you like that. Given that you have a velocity time graph, okay, velocity time graph. Okay, so objective question, state the type of motion. A, they'll ask you, this is decreasing acceleration. B, increasing deceleration. Okay. C, maybe they say constant deceleration. D, decreasing or maybe constant acceleration. So A, B, C, D, which one is your answer? First, you ask yourself first, is it decelerate or accelerate? Yeah, Kirina say B. Is it decelerate or accelerate? If the velocity goes down, slowing down. Slowing down means what? Decelerate. Okay, slowing down. Yeah, Courtney also say B. Very good, well done. Slowing down. And then the curve becomes sharper. Okay, the curve becomes sharper. At first it's flat, then become more dramatic, right? It becomes very sharp. So it's increasing deceleration. It drops down very quickly. Answer is B. Okay, so this is more to prepare you for your objective. Okay, they might ask something like that. And I don't want you guys to get shocked because you never see any curvy V graph before, right? To draw, they won't ask you. Need to know how to state the type of motion though, right? They're all asking you on the gradient only. Okay, sorry. Every week I overshoot the time because this week I want to do a bit more. I want to catch up because we started the class a bit later on the 19th of May, and a lot of you guys are gonna sit for exam, and then you guys are having exam like 2.4, 2.5, 2.6. Okay, so I'm trying to catch up a bit. Okay, so if I'm too fast, if you really feel I'm a bit too fast, let me know. If you feel I'm a bit slow, also let me know. I'm trying to match the pace of the majority of you. Okay, I hope I don't leave anyone behind. So if you're faster, you just do the objective questions, okay, in class. Right, so this is the last class that is free already. Sadly, good things always come to an end. Okay, so I know there are a lot of people who, not a lot, there are some people who actually just they have never attended the class before. They just want the 4 free recording lessons. Okay, I'm okay with that. And then I know from the start they're not going to join the class, which is all right. Yeah, hold on, Jason. Which is all right. But now that it's the last free lesson, so to those of you who are not planning to continue, this might be the last time I'm seeing you. So good luck to you. Good luck with the subject. If in the future you need any help with anything, you can still WhatsApp me lah. Okay. All right. So yes, physical class. I want to check with you guys, right? How many of you are actually interested to have physical class? Do you feel that you study better with me being in front of you? Daniel say, Zach say yes. Jashan say yes. Okay. Yes, Zahan same time. Jaden also say yes. I will see lah, right? Because oh, Charisha said you prefer physical but don't have the transport there. Yeah, the thing is that actually, right, if the physical class is big enough, actually I would want to hope to split up physical and online, to be honest, because as a teacher, right, I know that you guys have some tuition that have physical and online at the same time when your teacher's there in the center and then teaching, and then you guys, some of you online, some of you physical. To manage the physical students and the online students at the same time, I feel to have my attention split out like that may be a bit unfair for those who are physically there, or a bit unfair to those who are online. So but I'll try to work out something. I'll ask you guys again. Maybe I'll put down a Google form or something, and then you guys just fill up and see who prefers physical class. If you guys can make it in the same time, then maybe we try to arrange, but maybe not next week. Okay, next week I think a bit too soon. Okay, so yeah, very late already. That one, don't worry, I will update in the group. Okay. So those of you who are continuing, see you next week. Those of you who are not, all the best. Okay, all the best. Decide what is best for you, and I hope to see you all next week. Okay, bye bye. Got any question you guys ask? Huh? Okay, bye bye. Bye bye.
Thank you, teacher.
Welcome. Welcome. Bye bye. Bye.